All right, let's talk about singular and non-singular matrix. This is very vital. It's a very vital concept in matrix because it gives us the opportunity to solve several questions being given. Now look at the two matrices we have in front of us. We have matrix A and matrix B. What we're going to do is we're going to try and test to see if any of these matrices are singular matrices. Of course, if a matrix is not singular, then we'll say the matrix. If a matrix is not singular, then we call it a non-singular matrix. And if this matrix is singular, we call it a singular matrix. All right. I hope you understand what I'm trying to say. So, how do we define a singular matrix? Well, if a matrix determinant, the determinant of a matrix gives us 0, then we call the matrix a singular matrix. That's the only definition for a singular matrix. So a matrix is called singular when the determinant gives you 0. Obviously, that means for you to be able to resolve a matrix being singular or non-singular, you have to know how to solve the determinant of a matrix. So let's try and investigate matrix A and matrix B. In matrix A, we have, let's find the determinant of matrix A. So the determinant of matrix A will obviously be the multiplication of this leading diagonal minus the multiplication of the other diagonal. So we have 2 times 4 minus 8 times 1. This is 8 minus 8. This is 0. Therefore, we immediately conclude that matrix A is singular. Let's investigate that of matrix B. To solve for the determinant of matrix B, what you have to do is to multiply the leading diagonal and subtract from the other diagonal. So let's find out. 1 times 2, that's 2 minus 18. So what we have here is minus 16. Now, minus 16 is non-zero. So we conclude that A is non-singular. A is non-singular. So the whole concept of singular or non-singular matrix is to find the determinant. As long as you get a value that is not 0, it could be positive or negative, then you define that matrix as being non-singular. So questions often come and you will see something in the form of a non-singular matrix. When you see something like that, they are only trying to tell you that the determinant of that matrix is not 0. And on the other side, you may see something like a singular matrix. All right, let's see the application of singular and non-singular matrix in a much more deeper situation. Now, this is a very vital aspect of the application of singularity of a matrix. Now, you're given a matrix A, and you can see the constituent of the matrix A. You are then told that the matrix A is a singular matrix, and you are asked to find the value for X. So understanding the concept of singularity of a matrix gives you a way forward in solving this question. Now, how do you go about this? Of course, if A is singular, that means determinant of A is equals to 0. That's the first thing you must identify. So you are sure now that the determinant of A is 0 because you are told the matrix A is singular. What do you use this for? Then you go on to try and resolve the determinant of matrix A, then equate it to 0. So what do you do next? To find the determinant of A, as I said already, it is multiplication of the leading diagonal minus the multiplication of the other diagonal. So what you have here for the determinant will be 2x times 3 minus 3 times 4. Then you would have 6x minus 12. 6x minus 12. Now don't forget that they told you that determinant is 0. Of course, as they told you that the matrix is a singular matrix, that was the implication. So you need to go on now to equate this to 0. And this will mean that 6x here will be equals to, you move this here, will be equals to 12. Obviously, our x will be equals to 12 over 6. And from there, we would have our x being 3. So you can easily find out the value for x by understanding the concept of singularity of a matrix. So we've been able to find the value of x here as 3. X equals to 3. All right, let's try and solve this question we have right here. If you can attempt it, you can pause the video right here and tell me what your answer is in the comment section. All right, looking at this question, you're told to resolve the value for x, given that this matrix A is singular. Of course, you should know already that when you say a matrix is singular, that means the determinant of A will be 0. So let's try and find the determinant of this matrix A. Of course, the leading diagonal minus the other diagonal. So we have determinant of A will be 2x times x minus 4 times 8. You then go on to resolve this to be 2x squared minus 32. Now, given that the determinant of A is given as 0, we can go on to equate this to 0. We then have 2x squared equals to 32. We then have, dividing both sides by 2, we have our x squared to be equals to 32 over 2, which is 16. So we have our x squared to be equals to 16. Then we can get the square root of both sides here. And then we are able to get our x to be equals to plus or minus 4. Because the square root of 16 is equals to plus or minus 4. So let me know if you got this in the comment section below. This is the application of the singularity of matrices. So you can go on to confirm your answers. If you fix in the value for x as 4, as plus 4, you'll be having 2 times plus 4 times 4 plus 4 plus 4, and then you have 8 here, you have 4 here. This will be 8 times 4, that will be 32. 32 minus 32, that will obviously give you 0, which proves that this matrix was singular. And if you go on to make use of the value of minus 4 here, you would have minus 4 times 2, that will be minus 8. Minus 8 times minus 4, that will be 32. Minus 32, it also equally gives you 0. So that proves that the answer being plus or minus 4 is absolutely correct. All right, I would love you to attempt this question, finding the value for x, given that A is singular. And you can drop your answer in the comment section below. Thank you guys for joining. I really hope to see you in the next video. Bye-bye.